You know, health is pretty much our most precious asset, right? But I want you to take a guess real quick. Right now, across the globe, what percentage of the human population lacks access to even basic, essential healthcare services? Just lock a number in your head for a second.
It's actually more than 50%. Yeah, over half the planet. Let that jarring statistic sink in for just a moment. More than half of the people on Earth simply cannot access the basic care they need. The stakes for global health are absolutely massive, and the system we rely on, well, it's pretty much reaching its breaking point.
Welcome to this explainer. Today, we're diving into something absolutely wild. Medicine is literally undergoing its most fundamental shift in history. We're standing right at the intersection of biology and artificial intelligence. And it's this convergence that's finally taking us out of the dark ages of reactive medicine and straight into a new era of predictive, preventative, and highly personalized care. Okay, let's just dive right in. Here's our roadmap. We'll start with medicine's trillion-dollar problem, move on to the AI and genomics solution, explore detecting cancer before symptoms, talk about curing the incurable, and wrap up with the global fight for equity.
Starting with Section 1, Medicine's trillion-dollar problem, the cost of imprecise care.
So, look, our current medical paradigm is fundamentally broken. Think about it. We wait for people to get sick, and then we react. In the US alone, the financial cost of this sort of imprecise medicine is close to $1 trillion every single year. Now, don't get me wrong, modern medicine is undeniably one of humanity's greatest achievements. I mean, it literally guided us out of a fatal global pandemic recently that would have cost millions more lives a century ago. But despite these miracles, relying entirely on a reactive approach is just astronomically expensive.
And taking a global view, it's just not equitable. According to World Bank data, over 2 billion people, 2 billion, face financial difficulties just trying to access clinical care. Part of the issue is that we often rely on these blanket treatments for wildly diverse human biology. A drug that works perfectly for one person might fail another entirely. That leads to wasted resources and prolonged illness. We basically have a system that's imprecise, financially draining, and simply out of reach for a massive portion of humanity.
Moving to Section 2, the AI and genomics solution, or revolutionary convergence.
This is where things get really exciting. We are finally shifting away from reactive healthcare over to predictive medicine. Right now, biology is the most data-rich field on Earth. Through modern genomics, we can generate these massive amounts of data about the human body, literally down to the molecular level. But human brains can't analyze that sheer volume of data alone. There's just no way. And that is exactly where artificial intelligence steps in. By feeding massive biological datasets into machine learning models, we can actually predict disease and intervene long before a patient even feels a single symptom.
Section 3. Detecting cancer before symptoms. Catching a weak disease early.
Now, what's really fascinating here is the data on 5-year survival rates from a UK National Health Service study. It paints a stark reality. Caught at stage 1, survival is around 90%. But if it's caught at stage 4, that survival rate plummets to just 6%. The message here is incredibly clear. Cancer is actually kind of a weak disease as long as you catch it early, but it's a death sentence if you catch it late. So the ultimate challenge has always been, how do we catch it early?
So you might be thinking, why not just do a liquid biopsy, a simple blood test? Well, traditional liquid biopsies have a massive problem. Your body has about 5.5 liters of blood. If a doctor draws a 5 milliliter sample, they're taking just 0.1% of your blood volume. If you have early-stage cancer, there are very few tumor bits floating around in there. Searching for those bits in that tiny sample is literally like looking for a needle in a haystack. And the danger here is staggering. If they don't find a tumor cell in that specific drop of blood, they might tell a patient they're cancer-free. This results in a dangerous, potentially fatal false negative, simply because the sample just didn't happen to capture that one cell.
But oh man, here is the absolute breakthrough. Traditional biopsies only work after a tumor has already formed. But researchers discovered that before a tumor even forms, there's this tiny epigenetic surface change on a stem cell that creates a cancer stem cell. Now, human researchers could never manually spot these complex changes across billions of data points. But AI models, they can do the heavy lifting, mapping these markers with incredible precision. This new AI-enabled epigenetic approach can actually spot the signatures of cancer a good 12 to 18 months before the tumor even forms. It's showing 80 to 90% sensitivity at stage 1. I mean, that completely changes the game.
All right, Section 4. Curing the incurable, engineering our biology.
For the longest time, for most non-communicable or genetic diseases, we didn't actually have cures, right? We only had treatments. You just managed the disease for the rest of your life. But through the power of genomics, we can now literally engineer biology. For example, gene therapy can now actually cure devastating blood disorders like thalassemia and sickle cell with just a single dose. Imagine that, a whole lifetime of suffering erased with one treatment. Now, to be fair, these engineered cures are currently highly expensive, sometimes $1 to $3 million per dose. But we have fundamentally crossed the threshold from lifetime management into actual, real cures.
And it's not just blood disorders, it's the brain too. This part really blows my mind. Traditionally, getting a molecular marker for a neuronal disease would require a highly invasive brain biopsy. But remember those stem cells we just talked about? Because stem cells are small enough to permeate the blood-brain barrier, they actually carry the molecular signatures of the brain right out into the bloodstream. This means we're now using simple, non-invasive blood tests to detect early pathway signatures for things like dementia, Parkinson's, and Alzheimer's. It's incredible.
Section 5. The Global Fight for Equity, Ensuring Safe and Fair Adoption.
Now, as amazing as all this miraculous technology is, there's a massive, massive red flag here. Right now, a staggering 90% of the world's genomic data belongs to people of European descent. Only 10% represents the rest of the world. And remember, AI is only as good as the data it's trained on. The World Health Organization warns that if we import models trained almost exclusively on high-income European descent populations and then just deploy them elsewhere, the embedded bias will cause massive harm. The models will inevitably misdiagnose and mistriage patients who simply don't match that initial training data.
So, flashy AI tools are basically useless and even dangerous without the right groundwork. A health minister can't just go out and shop for the coolest AI software. According to the WHO, for countries to adopt these technologies responsibly, they have to build 4 critical foundations. First up, they need high-quality, representative data. Second, interoperable systems, so diagnostics actually speak to health records seamlessly. Third, a trained workforce of doctors and nurses who actually understand how to interpret this new data. And finally, robust regulatory capacity to assign accountability if an AI system happens to make a medical mistake. Without these pillars securely in place, the technology will absolutely fail the people it's meant to serve.
So what does this all mean for us? It leaves us with this one incredibly heavy question. We're standing at a profound intersection right now. Will AI and genomics act as the great leveler, propelling low, middle, and high-income countries toward real health equity for all? Or will the nations that already have the data and resources just surge forward at lightning speed, leaving the rest of the world even farther behind? The future of medicine is already here, but ensuring it actually reaches everyone, well, that's our shared, urgent responsibility. Thanks so much for joining me for this explainer today. Keep questioning and keep learning.